Welcome back to The Explainer. Today, we're going to get into something really cool, a type of neural network that doesn't just learn to copy things, it actually learns how to clean them up. We're talking about denoising autoencoders. So let's start with a big question, right? In a world that's just full of messy, imperfect data, how do you teach a machine to see through all the static, all the noise, and find the real signal hidden underneath it all? Well, it turns out the answer is surprisingly elegant. Okay, but before we can get to the really clever part, we've got to lay some groundwork. We need to understand the basic building block here, which is the standard autoencoder. And you can really just think of it as a super fancy digital copy machine. At its core, a regular autoencoder's job is super simple. It takes some data in, runs it through an encoder that kind of squishes it down, and then a decoder that tries to build it back up. The whole goal is to make the final output look exactly like the original input. And this image is a perfect example. See that number 2? That's our input. It goes into the encoder, which compresses it into its most essential features. Then the decoder takes over, and its job is to rebuild that to perfectly. Seems easy enough, right? Well, not so fast. There's a potential problem here. Here's the thing. If the network has too much capacity, it might just get, lazy. Instead of actually learning what makes a 2 a 2, the curves and the lines, it might just learn a cheap shortcut, memorizing the pixels. It's like a student cramming for a test by memorizing the answers instead of understanding the material. This is what we call learning the identity function, and it's totally useless for our purposes. So how do we stop the network from taking that lazy route? How do we force it to actually learn something meaningful? Well, you give it a harder job. You throw a little twist into the training process. And the secret sauce here isn't making the network bigger or more complicated. Nope, it's much simpler than that. We just change what we're asking it to do. We change its goal. In machine learning speak, we tweak its cost function, which is basically how it grades its own performance. Okay, pay attention, because this slide is the whole shebang. On the left, you've got your regular autoencoder. It gets a clean input, we'll call it X, and its job is to spit out that same clean X. Simple. But now look at the right. The denoising autoencoder, or DAE, gets a messy, corrupted input. That's our X tilde. But its goal is to output the original clean X. See that? We feed it garbage and we ask for the pristine original back. That one tiny change, it's a total game changer. And that's the whole point, isn't it? The network can't just be lazy and copy pixel for pixel anymore. That strategy just won't work. To succeed, it has to figure out what the underlying data is supposed to look like. It's forced to learn the deep structure of the data so it can tell the difference between the signal and the noise. In short, it has to learn how to denoise. All right, so let's walk through how this actually works in practice. We're going to see how this one little change leads to a way smarter, more robust model. The training process is actually pretty easy to follow. Step 1, you grab a nice, clean piece of data. Step 2, you mess it up on purpose. You add some random noise or blotches to it. Step 3, you hand that noisy version to the network. And step 4, you tell it, okay, I gave you this corrupted thing, but I want you to give me back the original clean version. And you just do that over and over and over again. And boom, this is where the magic happens. Look at this. On the far left, those are the original perfect digits. In the middle, that's the garbage we fed the network, all noisy and corrupted. But look at the right. That is what the network spit out. It has learned to see through all that static and bring back the clean numbers. It's honestly incredible to watch. So let's just nail this down. Your standard autoencoder, it's a photocopier. It just makes a copy. But a denoising autoencoder, that's more like a professional art restorer. It takes a damaged piece and carefully reconstructs the original masterpiece. By making its job harder, by forcing it to deal with noise, we end up with a model that actually understands the art, not just the canvas. And that brings us to the big takeaway here. This isn't just a neat trick for cleaning up images. It's a really powerful idea, Sometimes the best way to get a deeper understanding is to make the problem harder, not easier. It really makes you wonder, if we can teach a machine to find a clear signal that's buried in a whole bunch of noise, what other incredible hidden patterns are just waiting for us to teach it how to find?